In this video, I'm going to go over a couple examples of graphing rational functions. As we go through, I have two examples. As I go through them, please pause often and try to work ahead. Practice it yourself, and then go back and get the video running to see if you can follow what I did or if you agree with me. So I'm going to first go over the main points, the guidelines. Again, rational functions is a function that's a ratio of two polynomials. So we have p of x divided by q of x. And when we're going to graph one of these, first thing we're going to do is we're going to look for the zeros, kind of like with polynomials. To find the zeros, the only way you make a fraction equal to 0 is if the numerator is 0. So you set p of x equal to 0, and you solve. For the vertical asymptotes, those are going to occur at places that are not in the domain. And again, when we have a fraction, what's going to make it not work? If the denominator is 0, it is not in the domain. So we set q of x equal to 0, we solve that. Now at this point, you watch out, because if you happen to have a 0 at the same place as a vertical asymptote, that's a place where you will end up with a hole and not an asymptote. So check, once you have your list of zeros, your list of vertical asymptotes, that there's no agreement, because if they're the same, that will not be an asymptote. It will be a hole in the graph. Next, we're going to find the end behavior, and hopefully we have a nice horizontal asymptote. Sometimes we don't. What we do with this is we just look at the leading term, the highest degree term of the numerator, divide by the highest degree term of the denominator, and simplify it. If you get it simplified down to a number over x, it's going to go down to 0. It's going to have a horizontal asymptote. If it simplifies just down to a number, it's going to settle down to some value and have a horizontal asymptote. That's going to be if the degree of the numerator is less than or equal to the degree of the denominator. If the degree of the numerator is greater than the denominator, then you're going to get one of these slant asymptotes, or worse. So you can approximate it by, again, simplifying that term. You take the numerator, the highest degree of the numerator, divide by the highest degree of the denominator, or you can get a better result, more exact, by just doing your polynomial division and just ignore the remainder. And once you take away that remainder, what you got as your quotient before the remainder is going to be your end behavior asymptote. Once you get those plotted on your graph, you're going to pick extra points to figure out what's going on between the asymptotes and the zeros. When you hit the asymptotes, which direction are you going? So that's our process. Let's see what we can do. First problem we're going to look at is this one, 8x squared plus 16x minus 120 divided by 4x squared plus 8x minus 12. So take a moment to see if you can find the zeros. I just changed that and it didn't. I hate that. Okay, my zeros are going to occur where the numerator is 0. So we're going to set 8x squared plus 16x minus 120 equal to 0. Always, it helps so much. Look for common factors. 8 is a common factor. It's divisible into all of those. So we can take 8 out. 2x minus 15. So that's going to be x and x. It's a negative 15, so a plus and a minus. So let's go plus 5 minus 3 to get 2. So you have a 0 at x equals a negative 5. You get a 0 at x equals 3. Next, we're going to look for the vertical asymptotes. Find vertical asymptote, we're going to take 4x squared plus 8x minus 12 to be 0. Again, we got a common factor of 4. X squared plus 2x minus 3 So that's going to be x and x, plus and minus, so plus 3 minus 1. So we have x equals a negative 3, x equals a positive 1. None of these cancel out, so we will have zeros here. We have our vertical asymptotes are great there. Now we'll look for our end behavior, hopefully a horizontal asymptote. We look at the leading terms, so we have 8x squared over 4x squared. Notice they're equal to the same degree, so we will have a horizontal asymptote. That cancels. 8 over 4 is 2. So I'll have a horizontal asymptote at y equals 2. So let's start sketching this and see what we get. Oh, that's just lovely. That's looking much better. And I'm just doing, it would be better to do this with graph paper, yes, but we're just doing a quick sketch here. So I have zeros at x equals a negative 5 and x equals 3. I have a vertical asymptote at x equals a negative 3 and another one at x equals 1. I have a horizontal asymptote at y equals 2. Okay, that's a lovely horizontal line. Okay, so to finish this up, I need to know on what's going on at the ends. So I want to know what happens at negative 10 and positive 10. I want to know between this 0 and the asymptote what's going to happen. So I'm going to try a negative 4. Between this one and, so here's 3, there's 1. So I'm going to try 2. For this little middle portion, I'm going to try kind of close to the asymptotes. So I'm going to try negative 2 and 0. And 2 points is only going to give me a line. So since there's more things going on, I don't have any zeros in here. I'm also going to try a negative 1 to find out what's going on between them. So at this time, I just plug these values into this function and see what I get. So if you want to sit there and do that, pause the video and do it. Let's see, I got 1.7 here, 1.8 here. So at 10, I'm at 1.8, about there. Negative 10, I'm at about 1.7. Negative 4, I got a negative 5.6. So that's about down here. At positive 2, I got a negative 5.6. Well, that's nice. Got a little symmetry looking like almost here. At negative 2, I got 10. At 0, I got 10. Again, I do know these can't mean that they have to be shooting up to infinity. They can't be going down to negative infinity because they're not crossing here. But my question is, how far does it go down? That's where that negative 1 helps me. That's at 8. So on here, I can see I'm going down to my asymptote this way, and I'm coming up to my horizontal. Same thing's coming down here. It's going down to negative infinity. It's coming up to that horizontal. And on here, it's going to go up this way, and so it should come around Your graph is going to look something like this. So that's what we get from our sketch. Now, if we look at decimals and let it help us out here, we put our zeros there. Here was our two vertical asymptotes, -1 and -3, our horizontal at y equals 2. Those are the points I plotted. And that's what the graph actually looks like, which pretty darn close to what we got here. So we're coming back here. We're going to look at this one. 4x cubed plus 4x squared minus 48x over 3x squared minus 48. Let's bring up my worksheet. So again, we're going to start off finding the zeros. So show me what you can do. Well, you can't show me what you can do. See what you can do. Take this down a tad. Okay, again for my zeros. 4x cubed plus 4x squared minus 48x equals 0. I have a common factor of 4x in there. So x squared plus x minus 12 equals 0. So that's going to be x and x, plus and minus, so we'll go plus 4 minus 3. So you have a 0 at x equals 0, a 0 at x equals -4, and a 0 at x equals 3. Now we'll work on the vertical asymptotes. (3x squared minus 48 equals 0). This has a common factor of 3. This, if you recognize it, it's a difference of 2 squares. So that's going to be x plus 4, x minus 4. We have a vertical asymptote at x equals a -4 and at x equals a +4. But now we see what we're talking about. I have a 0 at x equals -4 and a vertical asymptote at x equals 4. So I'm going to cross those two out. So I'll have zeros at x equals 0, x equals 3, vertical asymptote at x equals 4. Now for my horizontal, or my end behavior, I'm going to look at y equals 4x cubed over 3x squared, which is going to be 4/3 x. So this will be a slant asymptote. Now, if I want to get this a little bit more exact, I'll do the long division. 4x cubed plus 4x squared minus 48x plus 0 divided by 3x squared minus 48. So that's going to be 4/3 x. Oops, this is doing. Let me give me a little more room to work here. (4/3 x). So that's going to give me 4x cubed. I have no x squareds. And then I'm going to get 48 times 4/3 is going to be 64x. And that's a negative. So I will subtract that. And so I get 0, I get 4x squared, -48 minus a -64. going to be plus 64 is going to give me 16x plus 0. Divide by 3x squared again. I get 4/3. That's going to give me 4x squared plus 0x minus 64. And I get my remainder is 16x plus 64. But, as I said, if I look at that, would be, say, 16x plus 64 over 3x squared minus 48. But when x is large, again, I'm going to have a degree of the denominator is greater, so this will go to 0. So for the end behavior, it's actually going to be 4/3 x plus 4/3. Pretty close to this 4/3 x, but that will be a little better one would be y equals 4/3 x plus 4/3 for my slant asymptote. So when I come and I try to graph this, let's make this a little smaller so I can fit it all in here. Now sometimes when you set this up, it helps if you plugged in and found your extra points first. Sometimes it's kind of hard to do that. This is where the computer is nice. I've done this ahead of time, so I know how high I need to get up here. So again, I plot my zeros. I got a 0 at 0, a 0 at 3. I have a vertical asymptote at 4. My slant asymptote is going to be 4/3 x plus 4/3. So I come about here. I'm going to go up 4 over 3, up 4 over 3. My slant asymptote is going to look kind of like this, and it's going to be in between these. So I need some more points to plot. So I need something between my two zeros. So I'm going to try 1 and 2. That should tell me which way my asymptote, well, hopefully should tell me which way I'm going here. Let's pick something off on this end. So I'm going to try -5, see where we're at. On this side, I'm going to try, as I'm closer, 5 and something a little farther away, so I'll try 10. At 1, I got 0.9, so I'm about there. At 2, when you plug 2 into the equation, you get 1.3, so that's just a little higher. So that's going up like this. Has to go down to the 0. There's no multiplicity on there, so I'm going through, so this is going to have to go down to the asymptote like this. This should be lining up on this end, but we'll plug in -5. -5 gives us -5.9. So at -5, we're about at there. And my line might be off a little bit. So it's looking like, yeah, it's just going to come. And this branch is what we call it. It's kind of like that. At 5, I get 13.3. So that's up about here. At 10, I get 15.6. So So I'm over here. Again, 2 points doesn't tell me too much, so I want something in between. I try 7. At 7, I got 12.4. And that's going to be about there. So we can see this is shooting up here. I know it's not going to go down because it can't ever cross the x-axis. There's no 0 to the right of the asymptote. But it's going to come down to about here or so and then end up down this way. So generally, this is what it's going to look like. We go over to Desmos and see what Desmos says when it has a little nicer than my quick sketch. Again, why it's nice to use graph paper. We plug our 2 zeros there at 0 and 3. We have our asymptote x equals 4. Here's my y equals 4/3 x plus 4/3. I plug in those points we got. And we see that's pretty much the graph I have. That looks so much nicer than the one I got. So again, to kind of remind you, find the zeros from the numerator. Find the vertical asymptotes from the denominator. Find the end behavior by the ratio of the leading terms. That kind of sets up your framework, and then plot a few more points so you can sketch it in. Have fun.